fractions, y is only going to be 4, not 8. But for now, because I'm just introducing the type of the types of fractions, an improper fraction, when you have a bigger number at the top and a smaller number at the bottom, your numerator is bigger than your denominator, that is an improper fraction. And this is not the lowest form of a fraction. We use improper fraction to solve the fraction because it makes it easier not to work with the other type of fraction, which is called the mixed fraction, which is your lowest form of your improper fraction. What is a mixed fraction? A mixed fraction is a combination of proper fraction and whole numbers. So if I move from an improper fraction and I want to go to a lower fraction, what I do is to say, how many of this denominator can go into the numerator? So I will say 4 goes how many times into the numerator? It goes 1 time. And I will also ask how many? If it goes 1 time, therefore it's 4. But there is a remainder, which means there is 3 that is remaining. So to represent that, we'll write it as 1, 3 over 4, because 4 goes 1 time into 7 and the remainder is 3. And sometimes you will get problems where you are given mixed fraction. You need to convert the mixed fraction into an improper fraction before you can solve the fraction. I'm not talking about those who are using the Casio calculator, because the Casio calculator has the capability to write the fraction nicely for you to work it out. But those with scientific calculators that are not Casio, you will need to calculate this manually, and you will have to learn how to move between an improper fraction and a mixed fraction. So let's look at how we apply the basic operation, especially addition and subtraction of fractions. Let's say we have 2 over 4 minus 1 over 4. Since we have the same common denominator, what is a denominator? A denominator is the value that is at the bottom. Remember that. What do I mean by common denominator? A common denominator, it means the bottom value for both fractions are the same. So if I have 2 over 4 minus 1 over 4, especially when I do subtraction or addition of fractions, it becomes easy. If the denominators are the same, we just subtract or add the numerators. So how do we do that? So we're going to say, because the denominator is the same, we keep the denominator as 4, and what we do, we just subtract what is at the top. And that will give us 2 minus 1 is 1 over 4. And that is subtraction of fractions. Easy. Easy peasy slick. What happens when I do not have common denominator? If I do not have a common denominator, it means my bottom values are different. For example, like this: 2 over 5 plus 1 over 10. My denominator is 5 and 10. Since I do not have the same denominator, I need to find the common denominator between the two. What do I mean by finding the common denominator? I need to find the number that both of my denominator can divide into that number and not leave any remainder. So it means the answer I should get when I divide these two values into that number, the answer should be a whole number. And if I look at 5 and 10, the only value at this point that I can find or I can come up with is 10, because 5 can go into 10 and 10 can go into 10. And 5 goes into 10 2 times. So therefore it means it does not leave any remainder. The answer is a whole number. And 10 goes 1 time into 10. So then how do I solve this? To solve this fraction, it's easy. All we say is 5 goes how many times into 10? We say it goes 2 times, and we're going to multiply by the value that is on the top. So we're going to say multiply by 2. 5 goes 2 times, multiply by 2 at the top. Plus, because there is an addition, then I do the second part of the fraction. It says 10 goes how many times into 10? It goes 1 time. Then it's 1 multiplied by 1. And the answer will be 2 times 2 is 4. Plus 1 times 1 is 1 divided by 10. Which then gives me 4 plus 1 is 5 over 10. And that will be my answer. But that is not the lowest form. When you work with fractions, you always have to simplify them to their lowest form. What do I mean? I know that 5 can go into 10 and 5 can go into 5. So therefore, I can simplify this even further. Therefore, 5 goes how many times into 5? 5 goes 1 time into 5, and it goes 2 times into 10. And the answer will be 1 over 2. And that will be my simplified form of a fraction of 2 over 5 plus 1 over 10. Any questions before I move into a complex one? You know that you are allowed to unmute and just talk to me. Because it seems like now I'm talking to myself. Okay, it's fine. I will continue talking to myself. So let's look at having a complex problem where we are given the mixed fraction and we have different denominators. So still remember, addition and subtraction have the same priority from the bottommost rule. So the fraction or this equation that we need to solve now, the problem that is in front of us has subtraction and addition. Therefore, it means I'm going to work from left to right. The other thing I'm noticing about my fractions is I have a mixed fraction there. 1 over 2. So I cannot do anything with that before I can change my mixed fraction to an improper fraction. So changing this, we say 2 multiplied by 1, which is the big one, divide, 2 multiplied by 1, and we're going to add 1 again, that 1 there. So we multiply there, and then we add that. So we say 2 multiplied by 1, it's 2, plus 1 gives us 3. We still keep our denominator, which is 2. So therefore, it means on this side, we will have 2 multiplied by 1 plus 1 is 3 over 2. And I can also double check. 2 goes how many times into 3? It goes 1 time, and the remainder will be 1 over 2. So it sounds fine. Then I'm going to repeat all the values so that I can solve the fractions. Now I can solve the fraction. If I look at this, I have 2, 6, and 3. And since subtraction and addition have the same priority, so I can work from left to right, then I can also solve them at the same time. Really does not matter. So I'm going to find the common denominator because I know once I have the common denominator and I'm working with addition and subtraction, it will make my life easier. So finding the common denominator, it will be 6 because 2 can go into 6 and 6 can go into 6 and 3 can go into 6. 2 goes how many times into 6? it goes 3 times. 3 times 3, so it goes 3 times, and 3 times 3 in the numerator, minus, because I still need to keep them, the subtract basic operator. 6 goes how many times into 6? It goes 1 time, times the numerator 1, plus, because of the addition, 3 goes how many times into 6? It goes 2 times, and multiply by 2 in the numerator. 3 times 3 is 9, minus 1 times 1 is 1, plus 2 times 2 is 4, divide by 6, and the answer will be 9 minus 1 plus 4 equals 12 over 6. And this is still not the lowest form of this fraction, because 6 can divide into 12 and 6 can go into 6. Therefore, 6 goes 1 time into 6, and it goes 2 times into 12. And the answer will be 2 over 1. And because this is a fraction, or this is divide by 1, any number to divide by 1, you can write it as 2. And the answer will just be 2. Since when I ask if you have any questions, you don't respond to me, there is your exercise. Simplify the following as far as possible. If you have any questions regarding the question, you can ask. And you have 5 minutes. When you are done, I will ask someone to help me unpack the answer with everybody, so that everybody who's here can be on the same page. If you agree with Elisma and Nasira, you can like their answers. You should have the button to like the options there, so that we can see if everybody agrees. You don't have to retype your answer again and again. Thank you, those who are already responding. Okay, so who wants to try? Who wants to unmute and help the others? Anybody? Nobody. So this session, am I the only one who's going to be talking? My voice is dying. Anybody? Yes, Kambega. That's weird. I can see that you are trying. Don't know why your voices are not coming out. Okay, so it seems there is a technical issue with the speaker and voice. Nobody? No problem. Okay. Anybody who wants to try? No one. Okay. Can you guys hear me?
Hello,
Because it seems like
Lizzie,
I'm
can you hear
to
me?
myself. Yes, I can hear you now. Oh, okay.
It's
So do you
Lisma.
want to, yes, do you want to try? Because I was worried that I am talking to myself. You guys are not hearing me.
I can hear you perfectly fine. I'm just scared. I've got a toddler and he's a bit wild. So if you hear him in the background, I
So it's
apologize.
like you are loud enough. He's quiet
Okay.
enough or she's quiet enough. We can't hear them, so you can continue.
Okay. So with your exercise, the common denominator will be 20. And then 4 times 5 is 20. So it must be 2 times 5 on top in brackets.
2 times 5.
Times 5.
Yes.
And then minus, and the next bracket will be 3 times 4 because 4 times 5 is 20.
So 5 goes 4 times.
Mm.
And you multiply with the numerator. Okay.
And the plus, and then the next brackets will be 1 times 10 because 2 times 10 gives you 20.
Okay. Times 1.
Okay, so then that will gives you 10 minus 12 and then plus 10 again over 20. And then that will give you 8 over 20. And you simplify it to 2 over 5 because it can be divided by 4, both numbers.
Okay. So 4 goes how many times into 8?
2 times?
And it goes how many times into 20?
5.
So then your answer will be 5 2/5, which is option number 3. And that's how you answer the questions.
Thank you.
I have another exercise, but I'm not going to ask you to do it right now. So you can do it on your own. If you have any questions, you can either discuss with me on the WhatsApp. I will share the details on how you can be part of the WhatsApp conversation later on at the end of the session. So this is another exercise that you can do on your own. When you watch the videos as well, you can pause the videos and do this exercise, or you can quickly write it up so that we can go to the next session. Okay, or you can even take a picture of the question. And now let's look at how we do multiplication and division. But first, we're going to start with the multiplication. It's easy multiplication. So when we multiply fractions, there are different methods that you can use to solve the multiplication problems. And I'm going to show you all 3 of them. Okay, so the first method that I'm going to show you is you multiply. I call it what you multiply at the top, you must multiply at the bottom. So when you multiply at the top, so we're going to multiply everything that is at the top with what is at the top, and we're going to multiply everything that is at the bottom with what is at the bottom. What I mean is, if I look at this, I'm going to say 1/4 multiplied by 2/6. That's the first method. Multiplying what is at the top with what is at the top will mean 1 multiplied by 2 is 2. 4 multiplied by 6. 4 multiplied by 6 is 24. And we need to also solve it to the lowest form. 2 goes 1 time into 2, and it goes 12 times into 24. That's the first method that you can use. The other method is to simplify. Simplifying, like we did the simplification here when we say 2 can go into 24, but it can go into 2. We can also find the same. So we can simplify things at the top, numerator with denominator on one side, and we can do the same with the other side. That's another method. So I'm going to repeat the same problem. 4 multiplied by 2/6. And to do this, because I'm simplifying, I can keep 1/4 because I cannot do anything with the 1. Because 1 can go into 4, it goes 4 times, and it still goes into 1 time. So the same, it will remain the same. And I can also say 2 goes how many times into 2? It goes 1 time, and it goes how many times into 6? It goes 3 times. And when I am done with that, I can come back to my first method of multiplication. I can multiply what is at the top with what is at the top, multiply what at the bottom with what is at the bottom. So my numerator will multiply with the numerator. 1 multiplied by 1 is 1. 4 multiplied by 3 is 12. That's one method. The second method, or the last method that I might show you, is we can simplify by looking cross-cross. So the numerator of the first one can divide into the denominator of the second fraction. The numerator of the second fraction can simplify with the denominator of the first fraction. And that's what I mean by crisscross. All methods should give me the same answer. So I have 1/4 multiplied by 2/6. And you must also remember this. This is only applicable for multiplication of fractions. You cannot do the simplification and the crisscross with addition and subtraction. Addition and subtraction, remember, it's find the common denominator. So now, with the crisscross, I need to simplify this even further. 2 goes how many times into 2? It goes 1 time into 2, and it goes 2 times into 4. Therefore, 1 times 1 is 1. 2 times 2 times 6 is 12. Even though I would have followed the same process that I've done with the rest. Let's go back. 1 over 4 multiply by 2 over 6. 1 and 6, we can't do much with it. 2 and 4, we can do something with it. So 2 can go how many times into 4? It goes 2 times. And 2 goes how many times into 2? It goes 1 time. You know that 1 and 6 can be, nothing can be done. And the answer here, 1 times 1 is 1. 2 times is 12. 2 times 6 is 12. And you can see that all of the answers are equal to 12. So whichever method you find useful, you can apply when you do multiplication of problems. Even when you have mixed fractions, it works the same. So how do we do this? The first thing you do with mixed fraction is to make them improper fractions. 4 multiplied by 3 is 12 plus 1 is 13. So it's 13 over 4 because 4 goes how many times into 13? It goes 4, 8, 12, 3 times. The remainder is 1 over 4. So it's the same. So I applied the same thing. 2 times 3 is 6 plus 1 is 7 over 3. And therefore, we can also find, can we multiply crisscross? Nothing. 3 cannot divide into 13 and 4 cannot divide into 7. And 4 and 13, they cannot simplify. 3 and 7 cannot simplify. What's left? Multiply what is at the top with what is at the top. So 13 multiplied by 7 is 91. And 4 multiplied by 3 is 12. What do I have? I have an improper fraction as an answer. The lowest form, I need to simplify it further. So 91 divided by 12, because 12 goes how many times into 91? 12 goes 7 times into 91. And what is my remainder? To find out what my remainder is, because I cannot make it up and know immediately, because on the calculator it tells me it's 7.58. I cannot write it as a decimal. I need to leave my answer as a fraction. In your module, you will see with the options, most of the time your answers will be a fraction unless they ask you for an option or they give you an option as a decimal. Then you need to convert it to a decimal. Since the answers are in a fraction mode, you always have to leave your answer as a fraction. So now, we said 12 goes 7 times into 91. How do I know what my remainder is? To know my remainder, I can just say 91 minus 12 times 7. So on my calculator, I can find out what 12 times 7 is. And 12 times 7 is 81. So 91 minus 80, sorry, it's 84. So 91 minus 84 is equals to 7. So therefore, it means my remainder is 7 over 12. And that will be my answer. And that's how you will find your remainder. So you will say 12 goes how many times? It goes 7 times into 91. What is my remainder? I do not know my remainder, but I can find what my 12 multiplied by 7 is, and I found it's 84. And I can subtract it from the 91 so that I can see how many remainders are there, because if I add 84 plus 7, I should get 91. And that's how you do multiplication of fractions. Now, I'm going to skip right into it. While you still have the multiplication in mind, I'm going to go and do the division. The reason being, division and multiplication of fraction works almost exactly the same. If I have a division of a fraction, there is a method that you can use, and that is a KCF. It's like KFC. So you won't forget. You just know that it's scrambled KFC. KCF. What KCF mean? Easy. The KCF method, it says keep the first fraction, change the sign to a multiplication, and then flip your second fraction. So we're going to keep the first one. We're going to divide. We're going to change the division to a multiplication, and then we're going to swap and flip. Our numerator for the second fraction becomes our denominator. Our denominator becomes our numerator. What do I mean by that? Let's do that. So we keep 6 over 7. We change the sign to a multiplication. We flip the second fraction. So flipping the second fraction means 14 becomes our new numerator. Divide by 3 becomes our new denominator. And when I have this, I can just simplify it even further because this is a multiplication. Remember, you can do what's at the top, multiply at the top, numerator multiply by numerator, denominator multiply by denominator, but we can even do the crisscross or the vertical simplification of the fraction. So at this point, 6 and 7 means we cannot do anything, and also 14 and 3 we cannot do anything. So it means we're going to apply the crisscross method to simplify across. So 3 goes 1 time into 3, and it goes 2 times into 6. 7 and 14 can simplify. 7 goes 1 time into 7, and it goes 2 times into 14. So we can also now apply the multiplication of what's at the top, multiply with what is at the top, and what is at the bottom, multiply with what is at the bottom. So 2 times 2 is 4. 1 times 1 is 1. I do not have to write 4 over 1 because any number divided by 1 is the same as that number. And that's how you do multiplication and division of fractions. What if we have a complex fraction like this one? And I can see here we have mixed fraction, we have division, and we have multiplication. From the Bodmer's rule, it says when the equation or any sum that I am, or a problem that I'm solving, and it has 2 basic operations of addition, multiplication and division, I work from left to right. So it has division and multiplication. They have the same priorities, and I know that with division, the sign changes to a multiplication, so I can work this fraction problem as one problem. So, but the first thing I need to do is to change the mixed fraction to a improper fraction. 3 multiplied by 1 is 3, plus 1 is 4 over 3. Divide. I'm going to keep it as it is because I'm not doing anything for now. I'm just changing the fraction, the mixed fractions. 4 multiplied by 2 is 8, plus 1 is 9 over 4. Multiply by 3 over 16. Now I can apply the KCF. I can only apply the KCF with the 2 fractions that are linked by the division. I'm going to leave the multiplication as it is because it doesn't have a division, so I should not do anything to that part. Even if I had an addition on this side, it should not affect what I do to the division. So the first part will always be the K. We're going to keep the first fraction before the division, and we're going to change the second, the basic operation from a division to a multiplication, and then we're going to flip only that. The KCF only works with the 2 fractions and the division sign. The others, we just repeat them as they are. So we keep 4 over 3. We change the sign to a multiplication. We flip the fraction to 9, from 9 over 4 to 4 over 9. And we can also keep the 3 over 16 fraction that is multiplying there. And now I can simplify the fraction further. Because this is multiplication, and with multiplication you can cross. So the first one, I can start here. 4 goes 1 time into 4, and it goes 4 times into 16. And 3 goes 1 time into 3, and I can also cross here. 3 goes 1 time into 3. Then I'm left with the 4, I'm left with the 1, I'm left with the 1, and I'm left with, at the bottom I have 1, and I have 9, and I have 4. But I can still simplify this further, because at the top I still have a 4, so 4 can go 1 time into 4, and it goes 1 time into this 4. So I can also now have an answer. 1 multiplied by 1 is 1, multiplied by 1 is 1. Divide by 1 multiplied by 9 is 9, multiplied by 1 is 9. And that will be my answer. Any question? If there are no questions, then I'm going to give you an exercise which will take us into the break as well. And when we come back from the break, then we're going to do, we can discuss that exercise and then let me see. So we will, we'll discuss that exercise and then do more exercises, 1 or 2 more exercises, and then the day is over for us. And there is your exercise. Let's see how far you can get by 5 to 7. I will check if you have the answers, and then probably I have another exercise. No, I don't have. So then we will go into break, and I will see you at 5 past. So we can do this, and then I will meet you again at 5 past 7. If you have any questions, you are free to
Also,
Ndwangu, can you please switch off your video? I think 10 minutes was long enough for us to take that break. Can you let me know if can we continue, or do you still need more minutes? Ndwangu, please switch off your video, because I think at the beginning of the session, we do alert everybody to have their videos off. Yay. Okay, Elisma says we can continue. So if there is nobody who okay, absence of people commenting. I see there 2 more people say yes, so we can just continue. Great. I saw that Atingosi already posted the answer, how he solved that. So it defeats the whole purpose now for me to also share with you. But thank you very much for sharing your workings. Let's see how we answer this question. Anybody who wants to explain out loud? How we solve the problem?
Okay, I'll go.
Thank you.
Okay, so firstly, where the division sign is, we're going to flip, well, apply the KCF method. So flip 6/7 to 7 times 6, change the sign to a multiplication sign. So you've got 1/3 times 7/6 times 3/1. And then you simplify. So 3 goes into 3 ones at the top, and 3 goes into 3 ones at the bottom. And then you can't simplify any further, so then you say 1 times 7, well, times 1, which gives you 7 on top. And at the bottom, 1 times 6 times 1, which is 6. So then you have an improper fraction. So you, so how many times does 6 go into 7, which is 1? And then 1 remainder, so 1/6.
Which is option 3. Okay, any question? Anyone with a question? Who is still lost? Are we all on the same page? Do we know how to add, subtract fraction, multiply and divide fractions? Anyone who wants us to repeat? If there is none, then let's do the exercises. You want to say something?
Yes, sorry, but it's only because I joined a bit late, so I don't really want to keep everybody up. I just missed the first part, which is the adding. I think it was the adding of a fraction. If you don't mind just running through it very quickly.
Nope, you are not wasting anybody's time. The purpose of today's session is also to make sure that everybody understands. So I'm going to make a black screen so I can explain again, going back. So addition, I hope you are able to see my red pen. Addition and subtraction of fraction. If I can recap again, we said if the denominator are the same, like 1/4 minus 2/4, the denominators are the same, we just add or subtract the powers. That's what we said. So, for example, we keep the denominator as 4 because it's the same. So our common denominator will remain 4. We say 4 goes how many times into 4 if we want to apply that method. Otherwise, we can just say we subtract the numerator. So therefore, we keep what is at the top as a subtraction. And then we go and say 1 minus 2, it's minus 2, minus 1. It keeps the value of the bigger number. Remember that? When we're doing addition and subtraction, it will keep the value of your bigger number. So it's, the bigger number here is 2, so it will be minus 1/4, and that is the answer for that. And we also said if we do not have the common denominator, the denominators are not the same. So if we have 1/4 plus 3/8, the denominators are different. So since the denominators are different, we need to find the common denominator. And we said the common denominator is the number that both of these denominators can divide into and not leave any remainder. And for this one, the common denominator is 8 because 4 and 8 can go into 8. 4 goes how many times into 8? It goes 2 times. 2 times 1 is 2. Plus 4 goes how many times into, 8 goes how many times into 8? It goes 1 time. 1 times 3 is 3. And therefore the answer we will have will be 2 plus 3, which is 5/8. And that's what I wanted to recap with you. So everybody now is on the same page. Are you happy?
Thank you, yes.
Thank you very much. Now let's do more exercises. And there is your first exercise. You have 5 minutes. I will come back after 5 minutes and recheck if everybody has done the exercise, and then we recap like we've been doing all along. If you get the answer, you can post it on the group, on the chat as well. And your 5 minutes starts now. See you after 5 minutes. You have 2 more minutes. Okay, are we ready with the answer? Are we still busy? Are we lost? Do you need help? You managing well? Talk to me. Ready with the answer. So Megan says she's ready. Elizabeth says she's confused. So let's help. Yes, this one is a bit difficult. And why are you not talking to me? Don't wait until time's up. Ask so I can give you hints as well. Okay, so this will be the last time I do something for you. So it means you must learn to ask if you are stuck, so we can unstuck you or assist you or nudge you to the right direction. Okay, so we have an addition, we have a division, we have a multiplication. So BODMAS, which always should be our way to say division and multiplication first, then addition and subtraction. So since we have division and multiplication, we're going to apply the KCF on that one. So it means the two outside of the KCF, we keep them as they are. So we're going to keep 5/9 plus with the addition sign, and we apply the KCF. So we keep 9/5. We flip, or we change the sign, then we flip 4/3. Then we keep our multiply by 5/2. I hope everybody got it up to that point. So now we have multiplication and addition. So multiplication comes before addition. So it means this part we leave as it is for now. We don't do anything to it. So it will be 5/9 plus we only work with the multiplication side. So we can simplify by looking at only the multiplication by applying the simplification method. 5 goes 1 time into 5, it goes 1 time into 5, because this is the only part that we're working with, where we are multiplying. And what else can we simplify? 2 goes 1 time into 2, and it goes 2 times into 4. And 3 goes 1 time into 3, and it goes how many times into 9? It goes 3 times into 9. And what am I left with? Then I'm left with 3 multiplied by 2 multiplied by 1, which is 6. And at the bottom, I'm left with 1 multiplied by 1 multiplied by 1, which is 1. I'm going to write over 1 because I'm still solving the problems. Only when I get to the answer, then I can round off, or I can remove the divide by 1 or to the power of 1, because it doesn't make sense. So since I'm still working with fraction, I'm leaving 6 over 1. Now I need to find a common denominator because I'm working with additions of fractions. So to find the common denominator, then I get 9 as my common denominator. 9 goes how many times into 9? It goes 1 time. 1 times 5 is 5. 1 goes how many times into 9? It goes 9 times. 9 times 6 equals 54. And the answer here will be 54 plus 5 gives us 59. Divide by 9. 9 goes how many times into 59? 59 divided by 9 is 6 times. The remainder, because I don't know what the remainder will be, so I say 6 multiplied by 9. It gives me 54 minus 59, which will give me minus 5, but it's fine. All right. What is it? That you didn't understand? Have you seen where you went wrong when you answered the question the first time? You always remember that the others, where it has a division side, don't get confused with the addition and the multiplications that are there. You're only going to look at the division, the fraction before the division sign and the fraction after the division sign. That's where you apply your KCF. When you have the multiplication, only the fraction before the multiplication and the fraction after the multiplication, you can only simplify those ones by doing the crisscross. The addition, you will have to find the common denominator. Any question?
Yes, I do have a question with the finding of the common denominators. So I understood the 5 times 1, but then I didn't understand how you got to the 54.
1 goes how many times into 9? It goes 9 times. 9 times 6?
Yes.
Is,
9 times, oh, okay, 9 times 6, okay.
Yes, so I skipped the part where I use the brackets to show you, because I feel after doing so many exercises, I don't have to keep on doing 9 goes 1 time, 1 times 5 into brackets. Sure. Because I could have done this step. We could have said it's 1 row. We could have said the step before everything else, we could have just said it is. The common denominator is 9. We could have said 1 goes how many times? It goes 1 times 5. Plus 1 goes how many times? It goes into 9. It goes 9 times. 9 times 6. And therefore, then we will have 5 plus 54 divided by 9. And 5 plus 54 will give us. So I just skip some of the steps.
Okay.
Any other question? If there are no questions, we have one more exercise. If you look at the answer that needs to be for this exercise, You must look very careful. You have a multiplication, you have an addition and subtract and addition. So it means you first need to solve the multiplication and division. And then, but the first part of everything is to change that. So your first step is to change the mixed fractions, all of them, before you do anything. Then number 2 is to apply the KCF on the division side, which is only on this part, after you have changed to an improper fraction. And then number 3, what you are asked is to solve the multiplication, because then your KCF will change your division into a multiplication, and just only solve the multiplication and then look at the answer from the options that you have. It might be that you don't even need to change the mixed fraction. It might be that you will need to change the mixed fraction of the addition side. So that is your exercise number 2. You only have 3 minutes because it's easy. You don't have to solve the whole problem. I see already there are answers coming through, so it means people know what they are doing. So let's help those who might not know what to do. Anybody who volunteer? So that we look at the last question. And some of these questions that I'm asking you comes from your past exam paper. I didn't make them up, so I'm using your questions from your past exam paper or your past tutorial letters. But not actually your current one, because I do not have one. If anybody is kind enough to share, you can email the tutorial letter, or you can post it on WhatsApp if you have the details of the WhatsApp. So since we are left with 6 more minutes, how did you answer this question? Anybody? Oh gosh. Anybody? Nobody. Okay. So to answer the question, since nobody wants to help, so we first need to change, that's what we need to do, change the mixed fractions. So 9 times 2 is 18, plus 7 is equals to 25 over 9. Multiply by 3 over 4, because that's the only thing we're going to be doing. Divide by 3 times 8 is it's 24 plus 1. Okay. Plus 1 is 25 over 8, plus 3 times 3 is 9, plus 1 is 10 over 3. Now we need to apply the KCF. Remember, it's only for those two. The rest can stay as they are. So 25 over 9 multiply by 3 over 4. Change the sign to a multiplication. Flip the fraction so that the numerator becomes 8 and my denominator becomes 25. Plus 10 over 3. Now, applying the BODMAS rule, I can just only solve the fraction side. Solving the fraction, it means I need to simplify this fraction. So I can start here, 25 and 25 will cancel because it's 25 goes 1 times each way. 9 and 3, 3 goes 1 time and it goes 3 times into 9. 8 and 4, 4 goes 1 time and 4 goes 2 times. What am I left with at the top when after I've done my multiplication? I am left with 1 times 1 times 2 is 2. 3 times 1 times 1 is 3, plus 10 over 3. Before I can even do anything any further, I can just come here and say, this is not correct, this is not correct, this is not correct, but that is correct. And I can look at it and say, this is option number 4. I am not going to do the last one. So this will be your second other question that you can do on your own. And if you are able to solve it, you can share with us on WhatsApp, or you can email me. You have my email address, I think. From last week, I think I shared my email address. Otherwise, I can also share with you again my email address tonight. So this, you need to simplify this fraction. If you are looking at this, you can see that you have a fraction and a divide and a division sign there and another fraction. So you can rewrite this as 8 over 9 divide by 7 over 15. That's all what you can do, and then apply the KCF method. And you will find your answer that you are looking for when you solve the problem. At this point, this concludes today's session. If I can recap, we've learned how to work out the fractions today. We looked at how do we apply the basic operation of addition and multiplication, addition and subtraction of fraction. If they have common denominator, we just take the common denominator and we subtract or add the numerators. If they do not have the common denominator, we need to find the common denominator, which is a value that both of the denominators can divide into and not leave any remainder. Then we also looked at multiplication of fraction. It's easy. I showed you 3 ways of doing the multiplication of fraction. I said we can multiply what is at the top with what is at the top, what is at the bottom with what is at the bottom, and we need to also simplify the fractions to their lowest form. And we also looked at if we do a diagonal crisscross simplification, if we simplify the numerator of the first fraction with the denominator of the first fraction, and also vice versa. We also look at the vertical simplification, simplifying what is at the top, which is your numerator with your denominator on the first fraction, and also you can do on the second fraction. We also looked at the division of fraction, and we said with division of fraction, we can apply the method of KCF. Keep the first fraction, change the sign to a multiplication, and flip the second fraction. Your numerator becomes your denominator, your denominator becomes your numerator, and then it's a multiplication of fraction. Then you work, you simplify your fraction by either doing the crisscross, the up and down, or the top by the top. The other thing that we spoke about is simplifying your fractions to the lowest form. We also spoke about mixed fractions and improper fractions. To say a improper fraction, the lowest form of it will be a mixed fraction. And we can move from a mixed fraction when we want to solve the fraction to an improper fraction. Those who are using the Casio calculator, in the exam, it's going to be very easy for you to use your fraction calculator to calculate the fraction. At the moment, I am not going to show you how to use your calculator out of time. And those who want to join the WhatsApp group so that we can continue with the conversation, that is the WhatsApp group link. Make sure when you type it on your phone, on your web browser, you type exactly as you see it on there. Do not type lower caps. Do not where there are no lower caps. So it needs to be a capital letter as like that. Those who want more additional assistance when it comes to the videos, I also have a link on there that will take you to my private site, which is not private, it's my public site, where I shared some of the videos that I started last semester. It does not contain all the videos because I ran out of time from recording some of the sessions, but you are more than welcome to go and watch those videos. They might be very helpful for you to do the assignment, because we might also not be able to, I might not be able to assist you with your assignment during all the tutorial sessions, because I know that your assignment 1 was due a long time ago as well. And probably now your assignment 2 is due, and we are only at the beginning of our tutorials. But don't be disappointed that I'm not going to help you, but we're still working towards your exam. So we will be able to write the exam and get those distinctions, and 100% we give them the memorandum, and they will use your copy as the memorandum to mark everybody's exam paper. I'm joking. But anyway, for more assistance, you can contact me. I have so many email addresses, but for now, I'm going to give you eBoy, EEM, at unisa.ac.za. That's still my email, or you can also find me on my private one. If I'm not looking at the UNISA one, it's eBoy at Pambili. Now I can't type. Pambili analytics.co. Oh, come on. .co.za. You can find me on those 2 email addresses. If you want to send me anything for me to check, or you want to discuss something that we don't want everybody to hear on the WhatsApp group, you can send an email onto those 2. Otherwise, thank you guys for coming. We are 5 minutes over time. Thank you very much for coming. I will see you next week, Monday, when we do counting rules and indexes. But I need to also say something. Oh, before you go, I hope nobody left. Before you go, since the tutorial session, I am not going to be able to cover everything. I need to say this because I nearly forgot about it. Every Friday from 6 o'clock, from 5 o'clock, yes, from 5 o'clock until 7 o'clock, we will have numeracy skills workshops. I think the email, you should have received the emails about that. I will also share it on WhatsApp if I can still remember. I think I've shared it with those who joined WhatsApp last week. I will share with you some of the topics because it's very important that you attend both these sessions, the Monday session and the Friday sessions. It is very, very important because on Monday session, we will not have enough time because the sessions are 1.5 hours. So we will not have enough time to cover all the components you are required to know before you go write the exam. But some of them, I have moved them to Friday session under the numeracy skills training, where we will do, as we did on Monday, we will do such. We will go through the content a little bit, but we will also do a lot of exercises like we've done today, but looking at the skills based. So there I can also show you how to use your calculator, how to do this and how to do that. So it's very important. I am sorry that I am taking up your data and your time, but I needed to explain this to you so that you don't get confused when you look at the session for the tutorial and see that I'm not covering all the topic. I have moved some of them to the Friday session so that we have enough time. So you are so lucky. Thank you, guys. Thank you for coming. I will see you on Friday, not Monday. I will see you on Friday, and then I will also see you on Monday next week. Thank you, guys.
Thanks, Lizzie.